So now let's start with the definition of a systems of nonlinear equations. So what are systems of nonlinear equations? So systems of nonlinear equations consist of two or more equations with at least one equation that is not linear. So meaning to say that the given systems of equation is a piecewise function with two or more equations. So meaning to say two, three, or more equations with at least one equation that is not linear. So meaning to say that at least one equation that is not linear. So it is expected that in the given systems of equations, there are equations there that is quadratic or iconic sections of equations. So for example, given this piecewise function with the first equation x is equals to negative 3 as our equation number 1, then the second one is y is equals to x plus 3 squared minus 1 as our second equation. So observe, class, that the given piecewise function consists of two equations, right? Yes, the first equation is a linear equation, right? Yes, the first equation is a linear equation. Then the second one is a quadratic function. So recall that the graph of a quadratic equation is a parabola in which a parabola is belongs to a conic section, right? Yes. So next, let's tackle about the solutions of systems of nonlinear equations. So what are the solution of systems of nonlinear equations? So a solution of systems of nonlinear equation is an ordered pair. So meaning to say it consists of x and y terms, right? Yes, that makes all the equation in the system always true. So a solution of a systems of nonlinear equation, it could either be no solution or one or two or more or many solutions. So for example, consider the system of nonlinear equation of this given piecewise function, wherein the first equation is x is equals to negative 3, then the second equation is y is equals to x plus 3 squared minus 1. So the solution of this system is the ordered pair negative 3, negative 1. So we're going to check if the given ordinate or the given ordered pair is the solution of these systems of equation where x is equals to negative 3 are equation 1, then y is equals to x plus 3 squared minus 1 are equation 2. So we're going to check. So we're going to let x is equals to negative 3 and y is equals to negative 1. So using the equation 1, which is x is equals to negative 3, so since we let x is equals to negative 3, so apply the process of substitution. So that's negative 3, that's equal to negative 3. So that's true, right? Yes, then the second one, we're going to substitute or use equation 2, which is y is equals to x plus 3 squared minus 1. So substitution process, are we let y negative 1, so substitute negative 1 is equals to our x is negative 3 plus 3 squared minus 1. So simplifying further, that's negative 1 is equals to negative 3 plus 3, that's 0 squared minus 1, that's negative 1 is equals to negative 1. Simplifying further, so we can say that since negative 3 and negative 1 is a solution to both equations, so it is a solution to the system of nonlinear equations. So therefore, we can say that the ordered pair negative 3, negative 1 is a solution to a system of nonlinear equation given above. System of nonlinear equation.